Very good morning. First of all, thank you for coming to the class. Today, we will try to finish off the topic on DC to DC converter, which is on chopper. Okay, DC to DC converter, or also known as chopper. Okay, we have gone through the two quadrant chopper yesterday with some examples, one example, and I asked you to go back and do another example on this question, which is for mode 4, right? Is it? Mode 1 or mode 4? Mode 1. Anybody?
Mode 4, madam. We did mode 1.
We have done mode 1 in class, right?
Right.
So I asked you to go back and do mode 4. Have you done that? Have you tried? So now let's recap back on what we have looked through yesterday. Now this is a question on the golf cart. Okay, we have this golf cart can be operated in 4 modes. But yesterday we used a 2-quadrant chopper in order to control the speed of the motor. Okay, so for mode 1, it is forward motoring and 900 RPM with 85 rated torque. So mode 1 is in quadrant 1 because we have a positive speed forward, and also motoring means the speed and the torque have the same direction. Okay. Next, we have mode 2, which is reverse motoring with 500 RPM, 75% rated torque. Mode 2 will be reverse motoring. Reverse means you have negative speed, and because it is motoring means it also have negative torque, right? Okay. Motoring means the torque and the speed will have same direction. Okay. Now for mode 3, you have reverse braking at 450 RPM. So reverse braking means, the speed is negative, and braking means that you have, the speed is negative. This is one speed positive. The speed is negative. Braking means the torque have different direction with your speed. So it is in quadrant 4. Forward braking means speed is positive for mode 4, and you have negative torque because it is braking. Okay, so we have answered the question that the first question that this drive system cannot provide all the operation modes for the golf cart, and this only can operating in quadrant 1 and quadrant 2. So it is in mode 1 and mode 4, right? Are you okay up to here? All right. So we have done mode 1, and we already get the answer for VA and EA. IA is positive because the torque is positive, and this is the answer. Do you have any question for this mode 1 calculation? Okay, I want to ask you, for mode 1, is it EA, is it equal to EA rated or different? Is it equal to EA rated or not equal to EA rated? Anybody? Please answer the question. If you don't have question, I ask you so that I want to know whether you understand or not. For mode 1, the value of EA new, is it equal to EA rated or not equal to EA rated? Look at all the formula.
Then what? Not equal to EA rated.
So EA is not equal to EA rated. Because why? K flux is not equal to K flux rated. You have EA equal to K flux omega, right? So if K flux is changing, K flux will be less than K flux rated. Therefore, EA new will not equal to EA rated. Alright, you must know this. This is based on this formula. So anything you must refer to the formula provided before you answer. Okay, this is to make sure that you understand the question or the operation of two quadrant chopper. Alright, any more question? Or you want me to give question to you? No question. Okay, next. Have you done mode 4? Okay, this is the answer or the how to solve for mode 4. For mode 4, it is forward braking. It is 600 RPM and the torque is equal to rated torque. Okay, TE rated. It is in quadrant 2 operation. You have the speed of Nm and omega m positive. Okay, because it is forward, means the speed must be positive. Therefore, your VA and EA positive. Okay, what about the torque? In mode 4, the torque is negative. Yeah, the torque is negative. Therefore, IA also will be negative. So after you find the quadrant of operation, you must know, okay, which control strategy you want to use. Control strategy. So you will compare the operating speed and the rated speed. And in this case, the operating speed is 600, which is less than the rated speed, which is 800. Okay, so which control strategy? If the speed is less than the rated speed?
VA control.
VA control. So for VA control, flux will be equal to rated flux, and K flux also be equal to K flux rated, and VF is constant or equal to the rated VF. Alright. So what about the torque? Now we have the torque. We already calculate the torque, and we get from the first question we get the torque equal to 23.87. Now it said that for this question it is equal to the rated torque, but the magnitude is the same, but you must make sure that you put negative here because this is in quadrant 2 operation. Yeah, quadrant 1. Quadrant 2, you have positive speed. Even though it said at rated torque, it has the same value at rated torque, but now you must put the negative part. Okay, the negative sign here. Due to forward braking, quadrant 2. Are you okay up to here? Okay, no matter
Yes,
what's
madam.
alright, thank you. No matter what's the value of torque, even it is said if it is say 60% of rated or what value it is, or it said rated torque, anything, but you must know if it is in quadrant 2, you must put the negative sign. Yeah, don't forget about this. Now, because VF equal to VF rated, automatically you can straight away calculate your firing angle for the field winding, delta F, by using this formula. Okay, this formula is for 2 quadrant chopper. Okay, this one 2 quadrant chopper also. Right. Now, in order to calculate for del 1, we must have VA, right? VA new, because this is VA control. In order to calculate for VA new, we must have EA. Okay, EA new. And how to calculate your EA new? Okay, by using this formula. What's the value of K flux? Because K flux is constant, we take the value of 1.325, but now the speed is equal to 600 RPM. Change to radian per second, you will get EA equal to 83.25. Okay, so in order to get VA, you also have to get your IA new, which is equal to torque over K flux rated. by using this formula. Okay. If you compare with yesterday's question, it's different because yesterday's is flux control and you come up with a quadratic equation, right? Now, for VA control, because the flux is at the rated flux, rated K flux equal to K flux rated. So straight away you can use 1.325 with the torque, okay, the new torque. But make sure you put negative at the new torque and you get the current IA equal to negative. So this is correct because now the torque is negative because you are in quadrant 2. Okay, so you must get IA equal to negative value. So putting all the values in this equation, VA equal to EA plus IARA, you will get VA equal to 74.24. And put in this equation, you will get the value of del 1. Okay? You get the same answer? Yes, no? Or you didn't do at home? Hello? Nobody respond. Are you okay up to here? Do you have any question? Am I alone in the class?
No, no problem, madam.
No problem. Okay. Next. Okay, now, today we will continue with 4-quadrant operation of chopper. As we are still at the same question, but I've changed a question a bit. Now, the first question, this is a theoretical question. Sometimes in the exam or in the test, this type of question will come out where you have to give reasons or to give opinions on what happened, on how to change the system or what. Yeah. So what must be changed in the drive system to enable the operation in all 4 modes? Okay. So what's your answer?
Make it into a 4-quadrant chopper.
Yes. So you have a load here. This is your motor. Okay. The motor here, it will be connected to your chopper. Previously, you learned AC kan, rectifier. So this time chopper, and this is your source. Okay, your DC source. Okay, DC source. So this is the connection. Okay, so if you want this system to operate in all 4 modes, this type of chopper must be changed to 4-quadrant chopper. Okay, so that the motor can go reverse motoring, reverse braking, forward motoring, and forward braking in order to drive the load. Okay, so you must change the chopper to 4-quadrant chopper. Alright, now next question. This one you can answer, you can put the answer. Change to 4-quadrant chopper. Okay, next, with the proposed change in the drive system, calculate the duty ratio for all choppers to operate the cart under mode 2 and mode 3. Okay, so if you still remember about the rectifier, okay, in the previous class, if you have 2-quadrant rectifier, you only calculate alpha 1 and alpha F, right? Alpha A, which is armature, and this is for field. For 4-quadrant, that I asked you, sorry, for 4-quadrant, yes, 4-quadrant, 3-phase. This one, single phase. Okay, for 4-quadrant, either it's single phase or 3-phase, if it is 4-quadrant, you have to calculate for alpha A1 because you have 2 legs, and alpha A2, and also you have to calculate for firing angle alpha F. You still remember this one? So for 4-quadrant, you will have 2 firing angles. The same as 4-quadrant chopper, you will have 2 duty ratios, and another one is for the field winding. So total are 3. So that's why you said duty ratio for all choppers. Yeah. Are you okay? So don't forget about this. If it is 4 quadrant, please calculate the duty ratio for all the chopper. So this is the 4 quadrant chopper. Okay, this is your source, DC source. And you have 2 legs, which are leg A and leg B. Okay, leg A and leg B. Both switches in each leg alternately switch on. Okay, so in each leg, let's say each leg A, you have T1 and T4. Only one switch can be operated at one time. Okay, sorry. Okay, so either T1 or T4 will be operating. In leg B, either T3 or T2. T1 and T4 cannot operating at the same time. Okay, and for leg A, you have the duty ratio D1, and for leg B, you have D2, or you can write down as DA and DB, duty ratio A and duty ratio B. Okay, and this leg A is connected to the motor. Okay, so the motor is connected between leg A and leg B, and this is positive VA, and if the current is flowing into this direction, so this is positive armature current. Okay, there are 2 legs and only one switch will be operating at one time for each leg. And to achieve certain DC motor speed and torque, you are using this formula to calculate the armature voltage. And then from the armature voltage, this is formula to determine the duty ratio of the chopper for both legs. Okay, the formula is not simple as the 2 quadrant, but this formula you don't have to memorize because it will be given to you at the back of the question paper. So VA equal to 2 del A minus 1 over VDC. So if you rearrange this formula, you will get DA equal to VA over VDC. So VDC plus 1 divide by 2. So you means you can times by half. Okay, half VA over VDC plus 1. Okay, this is the formula for alpha duty ratio A, means you have to calculate VA. For DB, duty ratio B, del B is equal to 1 minus duty ratio A. Okay? Are you okay? So for this 4 quadrant chopper, it can be operated in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Alright? Okay, for 4 quadrant, the operation of all 4 quadrants, VA and IA can be controlled in magnitude and polarity. Means that you can have positive VA, you can have negative VA, and positive IA, and also negative IA based on the quadrant of operation. Right? Okay, so this is for quadrant 1 operation. For quadrant 1 operation, when T1 is on, okay, this side leg A will be operating. T1 is on. The current is flowing by following the direction of IA and back to the negative terminal. T1 is on and T2 on. Okay, T1 is on and T2 also is on. Okay, one from leg A and another one from leg B. So in this case, straight away you can see that IA positive, okay, because it's flowing like this, and VA also positive. VA also positive. That's why it's in quadrant 1. Okay, you get positive speed. IA positive means you get positive torque. Alright. Okay, this one when T1 is off, T2 is still on, and the current will be circulating through D4. Okay. Okay, this is for quadrant 2 operation. For quadrant 2, T3 is off and T4 is off. Now it's biscalating like this. You have a negative voltage and negative current, right? Negative voltage or negative current? Negative current but positive voltage. V equal to VDC. Okay, so this one, it is circulating like this. T3 is off, T4 is on. And this one I've already put in my Brighton in my video. So you already had learned this in power electronics. I don't want to go through again. I want to go to the example. Okay. For those who want to understand the operation, you can watch the video in the Brighton. Okay. So next, let's look at this question. And as we said, this one is in quadrant. This one in which quadrant? Mode 1, forward, quadrant 1. This one, reverse motoring. It is in quadrant 3, right? This one, reverse braking.
Quadrant 4.
Which quadrant?
Quadrant 4.
Quadrant 4. And this is quadrant 2. So today, which quadrant we want to do? Is it quadrant 2 or quadrant 4? Can we do quadrant 4, which is mode 3? Okay, so the question is, right, now I choose quadrant, I choose mode 3. Okay, now we are using the 4 quadrant operation. This one should be 4 quadrant. And you have 4 quadrant, but still you have the field winding here. Okay, what field winding is still class A chopper. Class A chopper means it's 2 quadrant. So for field winding, you are still using the 2 quadrant chopper. But now for the system of golf cart, we change it to 4 quadrant in order for it to can be able to operate in all the mode. Okay, so now I choose mode 3. Okay, we want to do mode 3 now. Mode 3 is reverse braking. Okay. So if you didn't memorize, you can just draw this one. Okay, its reverse means the speed is negative. Its braking means the torque is positive. Okay, so it is in quadrant 3. Sorry. Reverse braking, this is torque positive here. I also got confused sometimes. This is torque positive or torque negative?
Torque positive.
This is positive, this is negative, right?
Yeah.
So reverse braking, is it quadrant 3 or quadrant 4? Should be in quadrant 4, right?
Yes.
Okay, because it's reverse and it's braking. Okay, so the sign must be different because it's braking. So quadrant 4, because the speed is positive but the torque is negative. Sorry, the speed is negative, the torque is positive. Okay, so I also have to draw this one to make sure. So I think better for you also to draw this graph to make sure you get the right quadrant. Now it's reverse braking. What's the speed now? Nm is equal to 600 RPM. 450 RPM. 450 RPM. Okay. Now, because it is in quadrant 4, so the speed now is negative. So, negative 400 RPM. Okay, in this question, it didn't put negative, right? It's just mentioned reverse. So, means reverse, the speed must be negative. Okay, you must put negative because it is in quadrant 4. Are you okay? So, you have to put negative on your own. Okay, because in the question, it's not given as negative. It said only reverse. So, if reverse, the speed must be negative. Now, what about the torque? The torque equal to 0.75 TE rated, the rated torque. Okay, what did we get for the rated torque previously? Please refer to your notes from yesterday's class. Berapa dapat?
23.87.
23.87. And if you calculate, what do you get for this torque? 0.75 from the rated torque. Please participate, yeah, guys. You want
17.90.
okay, 17.9 Newton meter. Is it positive or negative here?
Positive.
So positive because it is in quadrant 4. Yeah. So we have the speed, we have the torque, and we already specify that this is quadrant 4. Now, let's compare the operating speed and the rated speed. Now we want to choose a control strategy. After we know the quadrant, now we want to choose the control strategy. Okay, if we compare the operating speed and the rated speed, is it less than the rated speed or greater than the rated speed? Take the magnitude. Okay, take the magnitude. 450 and this is 800 is less than the rated speed. So if less than the rated speed, are you using VA control or flux control?
VA control.
Yes, VA control. Okay, you choose VA control. So in VA control, what will be constant? Constant as the rated value. So K flux will be equal to K flux rated. Okay, for VA control, K flux equal to K flux rated. VF equal to VF rated. And VF will be equal to 100 volt lah for the rated value. So for VA control, you must calculate new VA, yeah, new VA. In order to get your alpha duty ratio A. Okay. So how to do this? First of all, you must calculate all the duty ratio, means you must calculate duty ratio A, duty ratio B, and don't forget you have another one is duty ratio F. So there are 3 duty ratio that you have to calculate. So now you know that VF is at the constant as VF rated. So you can already calculate the duty ratio for the field winding, which is equal to del F equal to VF over V. Okay, this is 100 over 150. So equal to 0.667. Okay, this is duty ratio for the field winding because it said that the field winding is fed from class A chopper, means 2 quadrant. So you're still using the same equation for the field winding. Are you okay? So you already get one duty ratio, which is del F. Now you have to calculate for del A and del B. Are you okay up to here? Am I going too fast or too slow?
Okay, madam.
Okay. So proceed to next slide. In order to get del A, first you must calculate your VA new. You want to get VA new, you must have your EA new. Okay. And also you must have IA new. So this is the step. Okay. You must get your IA new, EA new, VA new. VA new, put all in this formula, then you can get your del A. So, how to calculate your VA new equal to EA new plus IA RA. Okay, you want to use this formula to get your VA, but you don't know this one and you don't know this one. Okay, how to get your EA? How to calculate your EA? You can get your EA from this formula. Okay, EA new equal to K flux omega. Okay, what's the value of K flux? What's the value of K flux? K flux equal to K flux rated, right?
Yes.
So this is VA control. So this is the value of K flux. Yeah, 1.325. Okay, what about the speed? What about the speed? Okay, you must use this. The new speed 450 times 2 pi over 60. Is this correct? Is this correct? Which quadrant of operation this one? It's in quadrant 4. So the speed should be negative, right?
Yes.
You must put negative here. Okay, don't forget to put negative here because it is in quadrant 4 operation. This one, the student always did careless mistake on this. They forgot to put negative. Okay, now put in your calculator, what do you get for EA? So this one, don't forget to put negative for quadrant 4 operation. Okay. So what do you get for your EA?
Negative 62.44 volt.
Okay, negative 62.444.
This is 62.44.
Okay, volt. Alright. Now we already get this one. What about IA? Okay, we want to find IA new now. Which formula you want to use? We already used this one. We have this formula, right? Okay. So these three formulas are very, very, very important. So please try to memorize it and know how to use it. Okay. So IA now equal to TE over K flux rated. What's the value of TE? You already calculate before this?
17.9.
17.9 over 1.325. Okay, this T, the torque, is it positive or negative?
Positive.
Positive because it is in quadrant 4. So we don't have to change anything. And you will get is equal to 13.51 ampere. So IA also positive because you have positive torque. Now you already have your IA, you already have your EA. Put this value in this equation and please calculate for your VA. Okay, please do that. Okay. Okay, I move to next slide. VA equal to EA plus IARA 62. Reluctance of 0.5. Okay, what do you get?
Negative 55.69.
5.69. volt. Okay, so this is your VA. Okay, if you are looking back at the notes from previous lecture, the magnitude of EA now is greater than magnitude of VA because it is in braking condition. Okay, this is lecture from the introduction to drive. Okay, you can go back and refer. So how to calculate your, now we have VA, alpha A, you must know your VA, right? From VA, to know VA, you must know EA and IA. Now you can calculate your del A, okay, by using this formula, duty ratio A equal to half VA over VDC plus 1. Okay, so the value of VA is minus 55.69. What about VDC? What's the value of VDC from the question? Which one you want to take? Is it 120? Is it 100? Is it 150? Which one?
150.
Yes, VDC is the supply to the chopper. Okay, so 55.69 over 150 plus 1, and you will get your duty ratio equal to 0.314. Okay, this is the answer. And in order to get the duty ratio for leg B, so this is duty ratio for leg A because you calculate for your VA, and this is duty ratio for leg B. You can use this formula. Duty ratio B equal to 1 minus 0.314, and this is equal to 0.686. Right? Are you okay? Do you have any question?
Okay, madam.
Okay, madam.
Okay. You have question? Do you have any question? Anything? No?
No question, madam.
No question. Okay, so that's the end of calculation for mode 3. Okay, so next, what another mode that we didn't do? Okay, let's look at mode 2. This one, I just go through very briefly and give the answer. Then you go back and try at home, okay? Mode 2 we didn't do yet, right?
Yeah, not
Yes,
yet.
madam. Not yet.
Okay, so mode 2, it is reverse motoring. Reverse means negative. Speed motoring means the torque and the speed have the same direction, so negative torque. Mode 2 is in quadrant 2. So quadrant 2, you have negative speed and negative torque. So your speed now is negative 500 RPM. And what about the torque? It's also 75% from the rated torque. We already calculated previously 0.75 from the rated torque. What do you get? 17.9 Newton meter, right? So this 17, is it positive or negative here?
Negative.
Negative here. Don't forget, it have the same magnitude. Okay, but now you have to change it to negative value. So all this value because it is in quadrant 2. Oh, sorry. Quadrant 2 ke ni? Quadrant 3. Right? Quadrant 3 operation. Okay? Boleh ke? Boleh eh? Now, You already get the quadrant. You want to choose the control strategy now. Okay, you have NM rated. So NM is 500, NM rated is 800. So 500 is less than 8. Oh, sorry. 500 is less than 800. So which control strategy?
VA control.
VA control. Okay. Because 500 is less than 800. For VA control, you repeat the same thing. K flux equal to K flux rated. Therefore, VF equal to VF rated and equal to 100. So K flux, for VA control, you must calculate your VA new. Okay, can you please do this letter at home? And I give you the answer. For alpha F, we get 0.667. For alpha A, you get 0.239. And alpha B equal to 0.761. Okay? And what I want you to do, after you have finished all the mode, you you put away your notes and to try to do this question again. Okay? By using 4-quadrant chopper and calculate for all mode 1, mode 2, mode 3. Start from finding the quadrant. Okay? It's a good practice for you. Okay? It's a good practice. In class, we have done together. Maybe you have to refer to the notes in order to find the relevant quadrant. You still have to look at the notes in order to find or to do the calculation for control strategy. But it is a good practice for preparation for tests, okay, or for the final. You put away your notes and try to derive or to understand the question from the beginning. Okay, what Pravin said? Something wrong with the Unit 10, what?
Madam, I think there's something wrong with the Unit 10 Live.
Pardon?
I think there's something wrong with the Unit 10 Live app. I can't scan the
QR code.
Yeah.
It's okay, it's okay. It's okay. So, this is what we have done for previously lah. For this one, for the previous question. VA is greater than EA. For motoring, the magnitude of VA is greater than EA. And for braking, the magnitude of EA is greater than VA. Okay, that's the conclusion of what we have done today. Now, so today we have finished the topic for DC to DC chopper. So we have gone through DC to DC rectifier, DC to DC chopper. And next week, we will go into a new topic, which is, I think, induction motor. Later, I will give you the notice, the class notice. So, now I want you to go to Brighton. Let me share the screen first. Okay, so in Brighton, there are a lot of practice problem for this chopper and also for the rectifier. Okay, and there are also videos that you can watch. In the video, there are also practice problem, okay, examples on how to calculate the duty ratio and also the firing angle for the rectifier. For firing angle for the rectifier, duty ratio for this topic. So, you go to converter, DC to DC. Please download this practice problem and try to do it at home. Okay, it's a good practice because with this, you will test whether it's braking or it is motoring. Okay, sometimes like this example. Can you see this example? I open
Yes,
this one.
ma'am.
Okay.
Yes, ma'am.
Okay, like this one, braking operation minus 500 RPM rated. Okay. It's dia bagi minus here. They already put the minus. And try to do this question. The answer is given. You try to understand. Yeah. And this is the practice problem for the chopper. Please download and try to do that. And we also have the practice problem for the rectifier. If you still didn't download it, please download the practice problem for the rectifier. The speed control strategy of the DC motor. Okay. This one, I think the control rectifier. Yes, control rectifier. Okay. Next, for next week on Monday, for Muslim on Saturday, on Sunday kan we'll be going to fast ke on Saturday? Saturday, right?
Sunday, I think.
Sunday, madam.
Sunday.
Oh, Sunday. So on Monday, do you want the class to be online? Are you going back to your kampung to celebrate Ramadan or not?
Yes,
Or you
madam.
are here in Unit 10?
At kampung, madam.
Huh?
Kat kampung, madam.
Kat kampung. So you want to class to be online on Monday? Who wants to be online or who want to be offline?
On Monday, madam.
Monday, yes, Monday.
Online can, madam.
Pardon? Online ah?
Online.
Can we have class online on Monday but Tuesday and Wednesday face to face? Is it okay? Okay, I want you to go through the induction motor drive for next week. Later, I will send a class notice for you to watch the video. Okay, there are also videos and notes for the induction motor. All right. So that's all for today, I think. If you have any question, please ask. Either you want to PM me or you can ask during in the Telegram. All right. Any more question?